Alright, this is a quick video on how you can build yourself an Intel Edison based smart connected sprinkler controller. Okay, first things first, parts. What do you need? You need an Ethernet to USB adapter. This one's on DigiKey, pretty cheap. You need an Intel Edison with the breakout board, important. Okay, you also need a Koyo, a PLC, or an AC relay board that can handle up to 24 volts AC. These are kind of expensive, but the relay boards are not. If you have one of these, awesome. You will learn how to do it. And if not, if you have a relay board, then you'll have to, make your own modifications. Okay. Let's get started with step number one. Step number one is you need to get into the connect your Edison. You need to connect your Edison via the USB console. I'm not going to explain how that's done. You can use screen to get in. Once you're in, you can use command control to make sure that your Wi-Fi is turned on, and you need to connect your Wi-Fi. Okay, I'm not going to go into that. There's bazillions of tutorials online. Next step. The next step is you want to use command control again to set up a manual IP address for the Ethernet controller. Make sure you've got that plugged in if you have not already. It's basically, I'm not going to show you how to do that either, but it's basically config, and then you do, Ethernet, whatever, manual IPv4, and then there's arguments there. Okay, something like that. Once you've got a manual IP address, we can continue to step number three. Step number three is you want to connect your Ethernet cable from the Edison to the Koyo, the PLC, and download and copy over to the Edison, probably via SCP, the Python Koyo library. This will help you interface with the Koyo. The important parts of this are how you initialize the device. It's asking for an IP address. Maybe you don't know the IP address. You can use plc.find Koyo to find it. This might be tricky because of the default route on the Edison. So if all else fails, what you can do is connect it to your home Ethernet. Run this Python library to find the Koyo, find the MAC address, and with the MAC address you can type in the new IP address. Zoom in so you can see that nice and clearly. Okay, that's it. So Python Koyo, step number four. Step number four is as soon as you have everything connected, presuming you've been able to establish a connection with the Koyo, if not, you're in trouble. Make sure that works first. We want our sprinkler controller to be connected and smart. So we've got Wi-Fi, we can connect to the internet, no problem. Let's get some data that we can use. What we want to do is only turn on the sprinkler. We want this to be a green sprinkler. Well, let's only turn it on when it needs water. So let's write a library to parse some data from this nice website from Agromet, usbr.gov. They will give you what's called evapotranspiration data, evapotranspiration. This will tell you how much you need to water your crops. In this specific instance, we're doing lawn. So there's a base ET number, and then there's a crop coefficient you apply to it. And this website also gives you, the type of crop. Several different types of crop. Has lawn, has potato, has peas, a whole bunch of different stuff. So write the library. If not, go to my website, turbozero.io, grab the library, because I've already done the hard work of parsing the data, which is in a text file and a real pain in the butt. And use that library. We'll use that library later on. Step number 5, let's write our sprinkler controller logic, right? This is what we are here for. And this should be actually really easy because Python, the Edison supports Python. Python's super easy. So what we'll do, we'll import our libraries. We need our COIO library, obviously, to interface with the PLC. We need URL-lib so we can get weather data, JSON so we can parse a config file, time so we can sleep for, turn on the sprinkler in a zone and sleep for the amount of time it should be on, which we will determine with a little bit of math. First, we'll pull down some weather underground information. We'll get the current forecast. We'll read that. We're going to parse it. We're going to get our precipitation. That's the main number we want. How much it's rained during the day. If it's rained more than we need to water our lawn, then we don't need to water our lawn. Rain's already taken care of that. Let's use our ET library, our evapotranspiration library. Love that word. And this is our weather station. We're going to get the crop lawn. This is what we're going to water. Now we're going to open up our config. What does our config look like? Let's take a look. Our config looks like this. It's a JSON file. It's got every zone. The ID, the type of crop, and the rate is probably the most important thing. I'm not using type right now, but you can with some modification to this code. The rate, the ID is what zone it's hooked up to on the PLC. So if it's hooked up to Y0, this is ID 0. Okay, Y1, ID 1, and so on and so forth. Okay, the rate will tell us how much our sprinkling system will measure. We'll water our lawn in 1 minute. So what I did is I turned on my sprinkler system for 10 minutes. I put this out on my lawn. It went up to 2 ounces, which is about 0.3 inches. So divide that by 10. If the sprinkler was going for 10 minutes, divide that by 10, and you get 0.03 inches. You will want to get the rate for each zone. I haven't done that. I'm using the same rate for every zone. I can fix that later, and so can you. All right, next, let's go back to our sprinkler. Now that we've got our config, we can let's get our zones, and let's iterate through our zones. Let's calculate how much we need. Now we have the forecast. This is how much we are supposed to have, and then we can subtract from that precipitation if it's rained. If it hasn't rained at all, or if the rain is great, let me back up. If the rain's greater than the forecast, we don't need to run our sprinkler system. The rain's already taken care of it. But if it's the precipitation is less than what we need, the forecast, then we need to calculate and we need to turn on a thing. So let's say we still need some water. We'll iterate through the zones. We will take our rate that we've entered into the config file per zone and divide still need by that rate. That will give us how long we need to run our sprinkler system. So what we'll do is we'll turn on the sprinkler for the ID, and then we'll sleep for our water time, which is in minutes. So we'll multiply that by 60 to get seconds. That's what time.sleep wants, and then we'll turn it off. Pretty simple. We'll go through each zone one by one and turn it on to sleep. That's it. Let's actually connect everything up to our old sprinkler system. So this is our old controller. It's a stupid one. It's not connected to the internet. You can set a schedule. That's nothing. Anybody can do that. Okay. So what we've done is we've disconnected. These are the blue ones. These are each zone. I have 5 zones. I've take a picture of this because you need to know which colors the wires you need to hook up. There's a color for each zone. I've taken it. I've put it up here. This is our COIO. This is our Edison. This is our Ethernet. It's connected into here. And then all our zones are connected up here. Okay. One of these, this is the common line, or this is plus 12 volts, plus 24 volts AC. That's our input. And coming down here. This is our controller is actually powering it. So we've got common line going into here and 24 volts coming out here. 20 volts are coming up here and powering our sprinkler system. Pretty easy to set up. Edison's in there. That's pretty much it. Okay, I forgot one thing. The old sprinkler system had a schedule. Schedules are easy. We can use System D that's built into the Intel Edison Yocto build to do that. What we'll do is we'll create a timer file. I've already created one. Here it is. It's pretty simple. Description, blah, blah, blah. This is the important part. On calendar, we want it to run every single day at this time, which is about 7:21 p.m. Then we want to install it. After we've got that copied over to, I've got it put in lib systemd system sprinkler.timer. Okay, I put it in there. You also need a service file. The service file needs to match, at least in name, the sprinkler file or the timer file. So if you have foo.timer, you need foo.service. I've got sprinkler.timer, so I need sprinkler.service. Here it is. The important part is right here. We're going to exec our sprinkler.py that we've made, and it should go. Copy that to the same location, which is in here. Then run system control enable sprinkler.timer. Boom. If it worked, you should see it in system control list timers. And if you can read that ugliness, it's right here, sprinkler.timer. We've got 5 hours and 48, that's when it last ran, 5 hours and 48 minutes ago. And we've got 1 hour and 49 minutes left before it will start again. Pretty awesome. So that's pretty much it. We've got a timer, we've got an efficient green sprinkling system that pulls data off the internet to understand weather conditions, understand how much it's evaporated, how much evaporation has happened, and transpiration has happened given our weather conditions. If it's rained, we're only going to water our lawn or our plants or our crop, whatever we're watering, for the exact amount it needs, no more, no less. And that's what we want. This is awesome. This is green. This is automatic. You don't have to worry about it. It's on a schedule. Bada bing, bada boom. That's it. Trib 0 out. What did you say? You don't think it works? You don't think it works? Let's see. It's not rain today. We need 0.11 inches of water. We're going to start at least zone 1 for 3.6 minutes. Let's go see if it turned on. Oh, look at that. Look at that. The sprinkler turned on. Oh, look at that. That's water. That is awesome. And that's a rainbow, a double rainbow across the sky. I don't know what it means, but it's awesome. It's a sprinkler. That's it. Trib 0 out. That was how you set up a smart sprinkling system in minutes. It's easy.